So as you saw in the warm-up, we had to identify what our radius was, and then we had to plug it in. So if we're plugging the diameter in for our radius, now we're starting off the problem incorrectly. We're not going to get the right answer, right? So we have to make sure that we're looking for the radius and not the diameter. Again, it's just a half line versus a full line. The formula for the volume of a sphere is just like we said, 4 pi r cubed over 3. Boom, just like that. Move it up. There you go.
Is that to the third power?
That is right. That is r cubed, or r to the third power.
How do we figure out that?
Good question. We'll get to that in just a second. That's actually going to be our first step. So remember, radius is half of a dotted line. Diameter is a full dotted line. In each of the problems that we're going to see today, you'll be given a picture of a sphere that either has a half dotted line or a full dotted line. So all you have to do is say, hey, look, there's a half dotted line. Boom, that's my radius. That's the number I'm going to plug in. If you see a full dotted line, what do you think you're going to have to do first? Figure out D? Well, yeah, it'll give you the D, but how do you figure out R from there? Divided by 2, right? You just cut it in half. Because half the diameter is the radius. So let's get some steps written down here. Is everyone all caught up on this, or we still need time? Need some time? Okay, we'll take another minute. It fell. Thank you. All right, step number 1. Identify your radius. Very straightforward. All you got to do is pick out, hey, there's my radius, and you've done step 1. But you're going to have to divide your diameter by 2 if your diagram has a full dotted line. Those of us that just got back, here's what we've got so far. The formula for the volume of a sphere is right there, bubbled up. And we've got our first step in this process written down. All you got to do is identify your radius. Once you identify what that radius is, you're going to do step number 2, which is to cube your radius. And again, cubing your radius just means we're doing r times r times r. We'll go through exactly how we're going to do this process using our calculators at the end once we get all of our steps written down. But there's the first 2 steps. Figure out what the radius is, then cube it. Multiply it by itself 3 times. The third step, whatever number that is, you're going to take that number and you're going to multiply that number by 3.14, the short version of pi. we talked about in, I think it was Unit 9 or something like that, with irrational versus rational numbers. Pi is an irrational number, right? It cannot be written as a fraction of two numbers, or two integers. Pi is roughly equal to 3.14159265389, blah, blah, blah. The numbers go on forever and ever and ever, and they never stop, right? Even right now, as we sit here, more digits of pi are being calculated by the second. It's an irrational number. It never ends, right? So we're just going to shorten it, 3.14. Nice and simple. Where's my... Oh. If you ever forget what pi is equal to, here's how you can remember it. Let me just grab this. So if you've got, oh, come on, 3.14 is pi, right? So 3.14, right? There it is. Hold on. 3.14. If you flip it around, what does it spell? It spells pi, right? P-I-E, pi. So 3.14, when we flip it around, it spells pi. So if you ever forget, that's one way to remember it. Now, you probably are thinking, oh, that's why they call it pi. Well, actually, no. Pi is just the name of the Greek letter that we use to represent this number, which looks like that, right? It just so happens that the first three digits, when flipped around backwards, or I guess we could say when reflected across the y-axis, it looks like it spells out pi, which is kind of fun. But exactly, just like most of math, right? So anyway, there you go. You can use that to remember what pi is equal to. We're just going to use 3.14, the abbreviated version. After you have that new number, what you're going to do is you're going to multiply that number, emphasis on that number, by 4. This might be a little bit hard to follow right now, but once we get to the calculators, it will be a whole lot easier for us.
My question is, I want to know what that number is.
It's the result of number 3. So essentially, you're starting with your radius, right? That's number 1.
But what's the radius?
Well, it depends on the problem, right? In some problems, the radius will be 1. Some it'll be 5.4. It depends on the problem. Once you identify your radius, that's your starting number. You're going to cube it and get a new number. Whatever that new number is, you're going to multiply it by 3.14, and you're going to get a new number, right? Then you're going to use that number and multiply it by 4. You see what I mean? So we're just building it out as we go. On the calculators, it's really self-explanatory, so just stay with me. Finally, the last step is we're going to divide this new number by 3. It won't be too bad. I'm going to leave these steps up here for like 30 seconds so we can copy the last one down before we get to an example. All right. I'll leave those last 2 there just in case you're still writing. Last 3. For example, go ahead and draw a nice sphere here. Start with a circle. Right? We're going to draw a solid curved line around the front of our sphere. And we're going to draw a dotted curved line to indicate the backside of our sphere. We've got a center point right in the middle. We can kind of see how this gives the illusion that this is a 3D shape on a 2D piece of paper. Yes? Now, let's say we've got a half dotted line with the number 5 above it.
Oh.
Okay? Good. Yeah, now you see how we're going to identify our radius, right? Let's go step by step by step. What's step 1? Actually, hold on. Let me clarify. I'm going to say 5 feet. Let's be more specific. 5 feet. All right, sorry. What's step 1?
Identify your radius, divide your diameter by 2.
Ooh, you're going a little too fast. Step 1. I'm talking for step 1. Oh, you're reading the rest of step 1, yeah. So, identify your radius. Is this a radius or is this a diameter that we're looking at?
Radius.
How do we know it's a radius? It's half a line, exactly. Right away we know that r is equal to 5. Not too bad for a first step, hopefully. But step 2 is we're going to take that 5 and we're going to cube it. So 5 times 5 times 5. Most of us have our computers out already, which is great.
125.
Perfect. So like I was saying, most of us have our computers out already. You can pull up a calculator. Just Google calculator. You guys know how to do it. And we get 125. All right, that's our new number to work forward on, 125. Step 3, what are we going to do with 125? We're going to multiply it by pi, but instead of putting in pi to our calculators, we're going to put 3.14. Anyone got a calculator out that can do that for me real quick? You said 392.5? Perfect, 392.5. So let me slow down here for a second. And let's take a look with the calculator at what we're doing. The radius is 5. If we do 5 times 5 times 5, can everyone see that okay? I know it's kind of hard.
Just barely.
Does that make it better? That makes it far worse. Let's readjust. Oops. Oh, there we go. That makes it look a lot better. Can you guys still see the left side?
Yeah.
Cool. Awesome. Oh yeah, you can see the calculator great with this slide. So 5 times 5 times 5, we get 125. We take that 125 and we multiply it. I don't even need to retype 125. I just hit multiply. It takes my previous answer. And I multiply it by 3.14. That gives us 392.5. What am I going to do with 392.5 in step 4?
You're going to multiply it by 4.
Multiply it by 4. We hit times 4. And we get what, Ben? 1570. Just like that. Step 5, we take 1570 and we divide it by what?
3.
3.
It's 52. It's 523.
523. I always want, or we want to do 2 decimal spaces. So 0.33. And this number repeats forever, right? This 3, 3, 3, 3, 3. It's going to be 3s for eternity. What do I put over those 2 3s? A line. Good. Flat line right on top. Because that line tells us that it doesn't just stop after 2 3s. It continues on with 3s forever. Which is nice for us to know because this means that we have a rational number as our answer, not an irrational number. What are my units going to be on my answer? 523 what? Feet cubed. Right? Not just feet, it's feet cubed.
So do we have to put that on each and every one?
That's right. You have to have your units. You have to have your units. Some of you guys saw on the Unit 11 test that we just got back this week. You got a point taken off the last question because even if you got that the height of the tree was 15, if you didn't write 15 feet, you got a point taken off. You have to include your units when you can. 523.33 feet cubed, or cubic feet. Now, what if the diagram that I'd given you looked like this? If we've got a circle, line in front, dotted line in back, dot in the middle. Yeah, what if it was a full line with 10 feet written above it? what would my step 1 here actually be to do? Divide it by 2. 10,
So it'd be 5.
that's right. 10 over 2 gives us a radius of 5.
So it'd be the same thing.
Exactly. Yes.
I think I get it.
Good.
Since
We're
you
gonna get.
basically broke it down to the simple.
That's right. Step by step is the simplest way to do it. But let me show you what I mean. We don't have to write all this out. This is a lot of writing. Okay? Let me show you in reality what it's going to look like for you. Let's say we go to our worksheet here and we're looking at number 1. What's my radius in number 1? 3. We're going to do 3 times 3 times 3. That's step 1. We're going to multiply that number by 3.14. That's step 2. We're going to multiply that number by 4. That's step 3. Oh, sorry, that's step 4. And then we're going to divide that number by 3. Boom, there's our answer. 113.04 centimeters cubed. How fun. We don't have to show work. Isn't that nice? As long as you're using these steps and plugging them in a calculator, you'll be good to go. Because like I said, you're going to need to know how to do this on the SBAC. You will have access to a digital calculator on the SBAC. But if you don't know what the steps are, you're not going to know what to do. Right? Couple things about the SBAC, just in case we don't remember from last year. You cannot use any notes. You cannot use any resources except for what's given to you in the program and what's locked into your brain at that point. All these types of angles, types of triangles, all these cheat sheets up on the board, those are all going to be covered during the SBAC. Okay? So you can't use any outside resources. It's all got to come from up here. Right? Just keep that in mind. So,
I feel like you could do everything except for like whatever in last.
say that one more time.
I feel like I could do everything except for what happened in last